So here we're going to look at how to use the t-table. So we'll use the t-table to find critical values when we're doing confidence intervals for mean with a small n, so an n less than 30, or when we're doing hypotheses tests with means n less than 30, so small n's, or when we're looking at comparing two means. So the most important thing, they're all important things. First important thing is over on the left, this column, degrees of freedom. So we've said if you've got a small n, the degrees of freedom is n minus 1. So you find your sample size, n, subtract 1, and that's how many degrees of freedom you have. And then for our purposes, this column here in the middle, so area in two tails is 0.05. We'll use this for confidence intervals and for two-tailed hypotheses tests. Okay, I'm always going to give 95% confidence intervals, and hypotheses tests will always have a significance level of 0.05. So for two-tailed tests, area in two tails is 0.05. For confidence intervals, 95% confidence intervals, this is the column we'll use. These are the critical values right here. The other column we'll use is this one right here, next to it to the right, where we've got area in one tail, 0.05. Okay, so these are the only two columns we'll need. These two columns, this last column, not important for our purposes. So just these two middle columns. So let's say I'm doing a hypothesis test, and I've got a two-tailed test to find critical values. I'm going to use this center column. So let's say my sample size is 22. That means my degrees of freedom are 21. So I go to 21, this row, over to here, the middle critical values are plus or minus 2.080. Okay. If I'm doing a 95% confidence interval and I've got a sample size of 14, that's a small n, so the degrees of freedom will be 14 minus 1, or 13. Here I've got the row of 13 degrees of freedom. Follow it over to the middle. That critical value for the calculation of the error is 2.160. For one-tailed hypothesis test, we'll use this column. So our rejection region, the critical value, the 0.05 will be in one tail. So this is the column we'll use. So say we had a right-tailed test and our sample size was 19. So degrees of freedom, 19 minus 1, here's 18. Go over to this column. The critical value will be positive 1.734. Okay. If we were going to do a left-tailed test, all we do is change the sign. So 19 in the sample, degrees of freedom 18. Move over here, the critical value would be negative 1.734. So despite the fact that the table only shows positive critical values, if you're looking at a left-tailed test, one-tailed test, the critical value will just be the negative of the number that appears here. And for a two-tailed test, you'll take plus or minus this value in the middle. So that's the t-table. Our purposes, these two columns. This stuff over here, this stuff over here, don't worry about. It's in here. Middle column for confidence intervals and two-tailed tests. This column for one-tailed tests.